We have enough number now?
Yeah,
Yeah.
they will come, but we can
Oh.
start. Let's start from the beginning.
Okay. So, students, in the last session, what we discussed was the basics of motion, about distance, displacement, velocity, speed, acceleration, uniform acceleration, and everything theoretical we have discussed. Today, what we are going to understand is how we can represent that on a graph. Represent everything, like, see, whatever quantity you are understanding. For example, distance, you always compare it with time, right? What is speed? Speed is distance upon time. So it is like, in what time what distance is being covered. So there is always two quantities being compared together. So distance versus time, or distance was velocity versus time graphs we have. I have a question. Does anyone had has anyone ever had a question like, why we need graphical representation of anything? Why graphs? You might have studied statistics, you might have learned about graphical representation of other aspects of data, of information. But my question is, why is it important? Why is it important to represent anything on a graph? What is a graph, and how does it help you to understand any concept better? Can anyone answer that?
Ma'am, it is used for uh, showing uniform, non-uniform speed.
No, I'm not specifically talking about motion, or specific about any distance time graph or velocity time graph. I'm specifically talking about general graphical representation. Why we represent anything on a graph paper. For example, like in the previous session, I told you that speed is distance upon time. So the distance covered upon time taken, when you divide the distance covered by time, you get the speed. Then why is it important to represent it on a graph? Any data, you see sports matches, football matches or cricket matches, why they represent anything on a graph or a pictorial representation? Why is there a pictorial representation?
Ma'am, we get the detailed information of a specific topic that we want to know about.
Okay. Okay, what else? What else can you? Yes, Sabri, you are
Ma'am,
trying to speak.
yes, ma'am, and graph is a convenient method for presenting some basic information, ma'am.
Correct, correct. So instead of writing every given information in details, in statements, we represent it through a graph, which can be easy to remember, which can be easy to understand, and that is why anything you will. Okay, there is one more thing I can give example for this. You read a book, you read a novel, or you read a lengthy paragraph or something, and let's talk about academics only. You read a paragraph or you read a chapter out of your textbook, and at the same time your teacher is going for an AV, an audio visual of that particular chapter. Which is more interesting for you, which is more easier for you to remember? The AV, right? The audio or video representation, or the pictorial representation. So whatever you see, your brain is functioning in that way. Whatever you see is more easily memorable for you as compared to what you try to understand through statements. So graphical representation is important to accommodate a lengthy information, a major information, in a very precise manner, in a very short manner. But in details, all the details will be covered in that particular graph. So that is why, like to answer my question, we represent anything, any data, any information on a graph paper to make it precise, make it easier to understand, and give all the details without missing out on details. Okay, so that is one thing. Why I'm raising such questions is whenever you study something, you need to have a one particular question: why you are studying this, why graphical representation is important. All right, so now we will move ahead with the graphical representation of distance and velocity on a graph. Correct? Okay. Give me a moment, I'll be sharing my screen. All right, is the screen visible to everyone?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes,
Okay.
ma'am.
So let's begin. Today, what we will understand is only three parts: graphical representation of motion, how we do it. Second, about distance time graph for uniform motion, for non uniform motion, how you can derive speed using that graph, and velocity time graphs for again uniform speed, non uniform speed, accelerated motion, and uniformly accelerated motion. Okay, let's understand. First of all, motion is described by line graphs. You know that line graphs show dependence of one physical quantity such as distance or velocity on another physical quantity such as time. See here, there is a precise diagram of a distance time graph and a velocity time graph. Whatever remains constant. Okay, see, understand, distance depends on time. With increase in time, the distance will increase, or it will go, you will drive farther, right? So it depends on time. So whatever is your reference quantity, the time is your reference quantity, that will be taken on the x-axis, and whatever changes according to your reference quantity will be taken on y-axis. So distance changes with time. Okay, so we write, or we represent time on the x-axis and we represent distance on the y-axis. Similarly, here a simple explanation of a velocity time graph is given, where when there is a constant acceleration, the line will be a slanting, increasing line. Velocity, when there is no acceleration, it will be a flat line. And deceleration, in retardation, it will be a slanting line moving downwards. We will understand this in detail in the upcoming parts. Okay. Now you understand here one thing. This is a distance time graph. Let's go ahead with the distance time graph, then you will realize what this is. See, distance time graph of an object moving with uniform speed. Now look at the graph. First of all, look at the graph. What has happened is we have taken distance in kilometers and time in minutes. With every passing minute, the distance in kilometers is increasing. See, for here, from 0 to 20 minutes, let's consider this is approximately about 10 to 11 minutes, because it's almost in middle, this point, which is represented at 10 or less than 10. Here, when it was 0, the time was also 0. It started at origin. Then when the time has increased to 10 minutes or 11 minutes, the distance has also increased to about 9 kilometers. So this means that the vehicle or the object has traveled about 10 kilometers or 9 kilometers in given time period. Similarly, the distance is increasing linearly, if you can see. It has traveled, uh, double the distance in double the time. It has traveled double the distance in double the time. So this is uniform motion, uniform speed. When distance covered is proportional to the time taken, the speed or the motion of the object is said to be uniform, correct? So you can see that the distance traveled by the object is directly proportional to the taken time. For uniform speed, distance time graph is a straight line. Obviously, it will be a straight line. As you can see from point O to point B, the line is straight. There is no distraction in the shape of the line. And obviously, the distance increases at a uniform rate. Okay. But when we go for, no, let's understand how to calculate the speed of this object from the graph. Now tell me something in this particular graph. How much distance has the object traveled from A to B? How can you derive? Like here, if you can see at a point A, the distance traveled is S1. We are not going into the quantities or the numbers. We are simply going into the general representation. So the distance traveled up till point A is S1 and up till point B it is S2. In what time? It has reached S1 at time T, T1, and it has reached point B, that is S2 at time T2. So what will be the speed? It will be the total distance covered. What will be the total distance covered? It is like from A to C. If you talk about linear distance, see the graph, the line, the slope shows what? The slope shows the increase in distance, but exact difference of distance is given, or difference of time is given by C, from A to C, the increase in time, and the difference in the distance is given by from A to B. So what will be B minus A? It will be S2 minus S1, that is the total distance covered from A to B. And what will be T2 minus T1? That is the total time taken from A to B, to reach from A to B. So how will you calculate the speed? To calculate the speed, we say consider a small part AB of the distance time graph. Draw a line parallel to the x-axis from point A and another line parallel to y-axis from point B. From point A parallel to x-axis, from point B parallel to y-axis. These two lines meet at a point C to form a triangle ABC. On the graph, AC denotes the time interval, that is T2 minus T1, while BC represents the distance S2 minus S1. Do you understand? BC, the perpendicular distance from final distance to initial distance. So what is your difference? S2 minus S1 is the total distance covered. And what is the time difference? C to A, that is T2 minus T1. So the object covers a distance of S2 minus S1 in time T2 minus T1. So the speed of the object is given by V is equal to S2 minus S1, velocity or speed, total distance upon total time. Is this part clear?
Yes, ma'am.
Yes,
Does
ma'am.
anyone have any doubts about how to calculate the speed of object? Please say yes or no so we can go ahead.
Yes,
No
ma'am.
doubts, ma'am.
Okay. Okay, fine. So now we move to distance time graph of an object moving with non-uniform speed. This is very basic. You can see with time the distance covered varies. It is increasing, but in 2 minutes, or in here it is meter and seconds. In 2 seconds, it has covered only hardly 1 meter. But in 4 seconds, it has gone to 4 meters approximate. So similarly, the distance is varying with time. It is varying with time, which is a sign of non-uniform speed. Correct? Okay. Moving on to velocity time graph. We talk about velocity time graph time graph of an object moving with uniform speed. Now, if the speed is uniform, can anybody tell me why there is a straight line from A to B? Why there is no
Ma'am,
slant?
because it is uniform speed, ma'am.
Which means the speed is not increasing or decreasing with time. That is why whatever the speed it is starting its journey with, that is let's say 50 km per hour from this graph, it is remaining constant with time. It does not mean, okay, I ask this question, does it mean that the object is steady? Who can answer this? The question is, if the velocity is not increasing, does this mean that the object is steady?
Yes, ma'am.
Does it mean that the object is steady and it is not moving?
No, ma'am, it is moving, ma'am, but with the same velocity it is moving, ma'am.
Exactly. With time, it is changing its position. It has reached from A to B as seen in the graph, but it has not increased its velocity. That means the acceleration of this object is zero. But the velocity is 2 hours to 6 hours. For continuously 4 hours, it has driven at a speed of 50 km per hour without accelerating or without retarding, without decelerating. Correct? So, what is the distance covered here? How will you derive the distance covered by the object? If
Velocity
you
into
are
time,
given a
ma'am.
velocity time graph, how will you derive the distance covered?
Ma'am, by multiplying velocity and time, ma'am.
So, what is velocity here? To the graph, tell me to the graph.
50, ma'am.
50 and time,
6 months.
is it 6?
6, ma'am.
Is
4,
it 6
ma'am.
hours? 4. Why? Because we have taken the velocity, sorry, not distance, velocity. And from point C to D, it is the time taken. So when you find out the area of this highlighted area, so displacement is nothing but the velocity times the time. area of A, B, C, D, E. As you can see, there is a polygon being formed A, B, C, D, E. Correct? Which is area of rectangle ABC and the area of triangle ADE. That is AB into BC, like we did it in the previous part, plus half AD in plus DE.
No doubts,
Today we
ma'am.
are going to understand this much because in the next session there is a numerical part which will include the equations of motion, the three equations of motion related to distance, velocity, and acceleration and time. The three major equations of motion. So we are going to understand this much. So a questionnaire for this session. Take 10 minutes and try to understand the questions given in this section. Okay, one after the other, you need to answer this. I cannot see the names of people, so anyone who knows the answer, please unmute yourself and answer this. Okay. First question: what is the nature of distance time graph for uniform and non uniform motion? First, let's answer for uniform motion. Nature means, is it a straight line? Is it a curved line? Is it a non linear line? Is it a parabola or a hyperbola? You need to answer that. So, what is the nature of distance time graph for uniform motion?
Madam, can you
Ma'am,
make
it's
it
like
bigger? That the
In
font is very
distance
small.
time graph, it forms a slanting line.
Ah, good.
Okay. Sir, actually, it's an image, so the disturbance is there, but I will speak out the questions. No problem. Okay, the nature of distance time graph will be a straight straight line, correct?
yes,
Non-uniform motion.
non-linear
Curved
line.
Curved
line.
line.
Okay. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? Please understand the question properly. What can you say about the motion of an object whose distance time graph? We are not talking about velocity time graph first thing. Distance
Stationary
time
motion,
graph
ma'am.
whose graph is a straight line parallel to the time axis.
Ma'am, then
Stationary motion,
distance
ma'am.
is zero, ma'am.
What?
Stationary motion, ma'am.
Stationary motion, there is nothing like a stationary motion. You can say that the object is stationary or not in motion, correct? Because
Yes,
there is no distance covered with increase in time. That means there is no motion of the object. Because if it is a line parallel to time, here there was this type of graph. See here, this one we are talking about. You see the line with straight line or a parallel line to time axis, the return word is stopped. This means that the vehicle or the object is stopped at that particular time, for that particular time period. It is not increasing, the distance is not increasing. That means the motion of the object is steady. Correct? Okay. Hmm. Again, we have a similar question. What can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis?
Constant speed, ma'am.
Huh?
Uniform motion, ma'am.
Uniform motion. That means motion with a uniform speed. What is the quantity which is measured by the area occupied below the velocity time graph?
Distance or displacement, ma'am.
Displacement or distance. Correct. Okay. Can you see this graph properly?
Yes, ma'am.
Yes, ma'am.
Okay. So the graph in the below figure shows the positions of a body at different times. Calculate the speed of body as it moves from A to B. Here, can you see A to B? I know it's a bit blurry, but you can make out where A is, where B is. Correct?
Yes, ma'am.
So what is the speed of the body as it goes from A to B? The time representations are 0, 2, 5, 7 and 10. And the distance is 1 to 8. If you have a pen and paper, please go through it. Fatafat, sorry, just have a habit of writing it down and let me know what is the speed from for the object when it moves from A to B.
Ma'am, 1 meter per second, ma'am.
How?
Ma'am, because the distance
This is a distance time graph. Okay, how much distance has it covered from A to B?
3 meter, ma'am.
3 meters, right? And the time taken is
3 seconds, ma'am.
from 2 to 5. That is 3 seconds. So 3 by 3, that is 1 meter per second. Correct. How about B to C? What is the speed of the object from B to C?
Ma'am, this is 0.6 meter per second, ma'am.
Why?
Ma'am, because the distance will be 3 meter and the time will be 2 seconds, ma'am.
But the graph is steady. The object is not moving. It is still at 3 meters.
Yes, ma'am. So the speed is 0, ma'am.
Correct. Correct. Don't make this mistake. Whenever you see a distance time graph whose graph is actually parallel to time axis, it means that the distance is zero covered. The covered distance is zero in that particular time period. So the object is still at 3 meters. It has not increased its distance. That means the velocity or the speed is zero. Okay. From C to D,
2 meter per second, ma'am.
from 3 to 8 meters it is going, right? Or 7 meters, 3 to 7 meters. So the distance covered is 4 and upon 2, correct, 7 to 9 seconds. Okay. So from C to D, its speed will be 2 meter per second. All right. Here, this is a velocity time graph. Is it clear again?
Yes, ma'am.
On y-axis, we have 0, 2, 4, 4.6 and 6 meters, meter per second. And on x-axis, on time graph, we have 0, 4, 10 and 12 seconds. Okay. So you have to calculate the acceleration during the first 2 seconds. How can you get the acceleration using velocity and time?
Ma'am, V minus U by T, ma'am.
V.
Minus U by T, ma'am.
Correct, correct. So go for it. Initial velocity minus final velocity minus initial velocity upon time. So for first 2 seconds, what will be the acceleration?
2.3, ma'am.
How?
Ma'am, because the initial velocity will be 0 and the final velocity will be 4.6, ma'am.
Correct. So 4.6 minus 0 upon 2, that is 2.3. Correct. Between second and the 10th second. Why this much time has been? Understand that the velocity time graph is steady. The line is steady from 2 seconds to 10 seconds, which means it is not increasing its velocity. So acceleration is 0. Understood or not?
Yes, ma'am.
Yes, ma'am.
Don't make this mistake. Try to understand the graph properly. There is no point of calculation here. From second to 10th second, the graph is parallel to x axis, time axis, which means with increase in time the velocity is not increasing. So v minus u itself is 0. So the entire acceleration becomes 0. Correct? Now go for the last 2 seconds, from 10 to 12 seconds.
Ma'am, negative 2.3, ma'am.
Correct. Negative 2.3, because there is a retardation. The acceleration will be taken negative because the speed is decreasing, velocity is decreasing. Correct. Okay. Here, the seventh question. A body is moving uniformly with a velocity of 5 meters per second. Find graphically the distance traveled by it in 5 seconds. For this, you will have to draw a graph on your own, and you will have to uh, submit that particular picture in the group. Okay, draw a graph and submit that picture. Take a picture of that graph and submit it in the group. All right. And eighth question, I do not have the graph written here by mistake. It has been cut out of the PDF, but I will share it with the share it in the group, and you can answer the questions of the question number 8. Okay. All right. So this is what we did today. We understood the graphical representation of motion and various types of graphs that we need to understand how an object moves. All right. So now, if anyone has any questions, we can take that now. Anyone? No questions, no doubts.
No, ma'am.
No doubts, ma'am.
No, ma'am.
Okay, okay then. I'll be sharing the PDF itself, presentation in the group. Also, I'll be giving you the questionnaire that I have kept in the last slide. It will be a clear image, more clear image, and I will share it in the group right away after the session. In the next session, we will understand the three equations of motion, which are very important theoretically to solve the numericals that you have. And we will cover some numericals based on those equations. All right. And then in the upcoming parts, we will understand the three laws of motion, which are again very important uh, as a part to understand force and other laws of motion, inertia, and everything. Correct? So, yeah, that's all for today's session. Next session will be a longer one because we will have numericals in that. So, I would suggest please be ready with your pen and paper, pen and notepad, so that you can easily solve those questions with us right here and we can get the solution right away. Okay. Just that make sure that you draw the graph of question number 7 given in the question paper and share that picture on the group. Correct? All right then. I think that's it for today. Sir, is that okay? Sir, are you there? All right, I think he is not available. Yeah, that's it. That's it from my side. I'll be sharing the presentation and the questions in the group itself. If you are from different groups, I'll be sharing in one group and so will forward it to all the groups. Okay. All right, then see you all in the next session. Bye bye.
Thank you,
Thank
ma'am.
you, ma'am.
Bye. Take
Thank you,
care.
ma'am. Bye, bye.
Bye, ma'am. Sir? Sir, పోయిందే